If you come back at 1:45, then we'll have a bit of time to talk about being open, being productive, electronic lab notebooks. I'd be really interested to hear what people in this community are using, because it's a somewhat tricky area for institutions to support at the moment. So I want to highlight the key person in my group who's been involved in this work for the past decade is Thomas Zielinski, but we're also working really closely with the Edinburgh Parallel Computing Centre, where 40 hardware developers and 40 software developers support research projects across Europe, and will be happy to support your projects as well. And these are the three that we've been working with. We're grateful to our funders. I'll come back to this Fairdom project, and we're currently located in the UK Centre for Mammalian Synthetic Biology. So I'm going to talk about data management. We understand data management. You create data and process it, analyze it, and publish the results. But increasingly, we're also invited to preserve, allow access to those same data so that other groups, potentially, can get a new set of publications by reusing those data. Christiana's data, others that we've heard about in this large-scale session, are great examples of that. And when we get that right, those data are the world's most valuable resource, according to the front page of The Economist. And when we get it wrong, our mismanagement, misprocessing, and misuse of data is a challenge to science's place in society as a whole, as The Economist was also very happy to say on another year. So what's the connection between the first part of data management and the second? Well, very often it's an institutional or community repository. That's how you get data from the first part to the reuse. So we've used a whole set of Arabidopsis data in my lab in the work I used to do, modeling the circadian clock and how it connects to metabolism and plant growth. We used a whole variety of different data, and variety is one of the dimensions of big in big data, this sort of rhythmic data especially. And this is what you might call the long tail. It's not the huge data sets we've been hearing about. It's this mass of small, diverse, but very focused, very high quality data sets which needs managing. We use them in the models. We asked other people to share their data with us, and we built a couple of different repositories to help them to share. They said they were willing to share. We needed the data. We built the repositories, and we got this. Nice library, empty shelves. And the sad reality is no one likes describing data to put it in a repository. And professional researchers are embarrassed to put their data in repositories if it hasn't been well described, just like coders are embarrassed to share their code if it hasn't been beautifully commented and annotated. And the upshot is that very little data is actually available of this long tail, and much of the code that we depend on isn't available either, although I'm sure what we just heard about probably is. So the answer to that is to tip the balance and to outweigh the cost, the labor cost of describing your data with some carrots. So carrots is Thomas's professional term for software tools that help you to make your day-to-day research easier, faster, more productive, so that the cost of describing the data is outweighed by the daily benefit of more and better research. This is just an example of Thomas's resource called BioDare2, where for rhythmic data, you get nice visualizations, processing of your time series, so you get period values, for example, faster than you could possibly do in Excel or any other way. And in BioDare2, he made a really nice user interface, so it looks pretty, it's very slick, and so forth. So, the hypothesis is that we'll get good data management if we provide the tools so that data management is just part of day-to-day research, part of the normal research workflow. And the problem about that is, where do you get the durability for that system? Where do you get the support? And now we come to the real crux, the nub of this problem of long-tail data management. It's an organizational problem. It's not a technical problem. You get the tools from your community. which has many really lovely qualities, but as well as producing very specific carrots, it's not that good at sustaining things. In contrast, repositories are typically backed by institutions, and although they can't be very specific, they can be very professionally managed, very broad. And the issue is to connect the tools and the repositories. That can't be done either by the research communities that produce tools necessarily, or certainly not by the institutions which provide the core broad repositories. So the hypothesis is that successful management of the long tail needs both institutions and researchers to work together. And the way they have to work together is to have some particular bits of software to make that connection. So luckily, we don't have to make those from scratch. The project I mentioned on the first slide, the Fairdom project, had already produced what seemed to us the best candidate software to make that connection. So Fairdom's an EU project, or it's a succession of EU projects. It's included significant BBSLC funding over many years, and it's produced two bits of software. The first is called OpenBiz, and this is more like a LIMS. It takes a workflow that you might have running in your lab where you're testing some plants, in this case, in a high throughput format. You provide some metadata in the form of what's in what well, and it spits out a worksheet, and then you get the data. In OpenBiz, you can customize the software so that it reads the files that you would produce and the machine would produce anyway, and combines them so that now your metadata is linked to all of those data files in a searchable repository, which is really nicely organized, and for free, the system will analyze the data. Work you'd have had to do anyway, but it's automatically triggered by dropping the files onto the system. So that's your time-saving benefit. Now, there is a key step here. You need a software developer to do that. Most labs wouldn't have that. That's why this sort of a system needs to be organized at the scale of a center or a department, perhaps. But it can then be customized for individual labs, and once you've got the job done once, it may well be relevant for other labs as well. The second part is even simpler. It's like a data catalog. It takes all of the different types of data that you need to do any particular research project and connects them, organizes them in a tree like this one. And then you can see it's really widely used by many projects. And then it allows you to wrap up that whole set of data, models, protocols, and publish it. So you can get a DOI, you submit the final set as your supplementary information. If you come back at 1:45, I'll show you that process working. It's a system where you can set it up in your own lab, as we have in synthesis, or you can do it yourself. This system is free on the web at that address. It's guaranteed to 2029, ready to use right now. So if you can't come at 1:45, don't stop your conversation. Just log on, make yourself an account, and you'll be away. Thanks very much.
Thanks very much, Andrew. We do have time for a quick question if anybody has a burning one. There we go. Everybody's going to save it for the later discussion. Okay.
Fine.
Thank you. Next up is Dan Pass from Millar.